Hello folks, this is video number 24 in support of the 3D Experience CATIA generative shape design application. At this point there are two playlists associated with this activity. One of them is called the wireframe tab, and the other one where this video is going to go into is the surface tab. The title of the presentation is actually, maybe I should say, it's a quick review and the terminology not really spelled out in the software or in the documentation for the software. Specifically, it's dealing with the sweep icon, which is one of the more advanced icons in 3D Experience CATIA, along with some other ones which are multi-section surfaces and blend and fill, etc. Fill is fairly straightforward actually, but sweep could be actually the most advanced option, and mainly because there's so many options that are available in that dialog box. Not all of them are mandatory, but one of the reasons it's so successful in the use of surface design and Class A surfacing using CATIA is because of these options, which are neither properly explained or documented or demonstrated in what's available to the average user. Now there's a lot of video tutorials on using sweep, but those also are dealing with the most basic uh, uh, exercises, which actually don't need the explanation. One does not have to know why is the surface generated looking like that in order to do those basic tutorials or videos. And I understand the reason for that. I'll come to that in a minute. First of all, if you are in the generative shape design and you look at the ribbon at the bottom of the screen and select the surface tab, you have the option of choosing sweep. And when you click on the sweep, you get this dialog box, and there is essentially 4 profile types. And the one that I'm going to be discussing is what is called the explicit one, where you actually draw something. And along with each one of these, for example, if you look at this particular one, it has 3 possibilities for the subtype. You'll see in a minute. And then there's a whole whack of stuff down here, which are the optional elements. The mandatory ones are only up here, but the optional ones, there's so many of them here. Now, there is some help, but this help doesn't tell you what's going on. As far as the why part, in other words, it shows you how and kind of what's every icon doing, what's every option doing briefly, but it doesn't really tell you what's going on. Now, and all these, even if you knew those and if you had use this thing, the only predictable results are for more or less super simple cases. Now, if you look at it, these 4 options, the first one, which is explicit, has 3 possibilities with it, and these other ones will have their own. Total of 21 different choices for sweep option. These are mandatory choices up here. But the one that we're discussing is only this explicit one, and the only one that I'm going to be discussing in this video is with the reference surface. Okay. So the best explanation that I came across is an educational document by the SAS system, which puts everything in, or at least in a very basic way in this slide. It says sweep is a surface generated by sweeping a profile. So here's a profile, you can see that. Here's a profile along a guide curve. Here's a guide curve, the blue one, with respect to spline. So in principle, these are all independent things. Okay. Now, sweeping a profile along a guide curve with respect to spine. So we have a profile sweeping along guide curve with respect to that spine. Essentially, internally involves planes generated which are normal to the spine, and the the profile is repeated on these planes. So here is, for example, here's the first step. Look, here's the spine. There are planes normal to the spine. So at every point along the guide, there is a perpendicular plane to the spine. I'm looking at that plane, and the profile is placed on that. So it's placed on the next one, and the next one, and the next one. And these surfaces, these repeated profiles, if you look at the surfaces that attach them together, it's called the uh, swept surface. Now, what does this mean repeated on these planes? And in this case, it's obvious. When you have a spine that's lined, this all makes sense. But if this spine is a three-dimensional, just hypothetically, a three-dimensional curve in space, what is going on? You still generate a surface. You can still do that. But the question is, why does it look like that? Could I have predicted? It's only doable for very basic, super simple spines, essentially. Now, in the nutshell, this is my 2 cents of what's going on here. So you have a profile here, you have a guide, and you have a spine. At every point in the spine, there is a normal to it, okay? And essentially, this original profile, this profile is somehow placed on that normal plane as you move the point along this path. So what do I mean by that? So for example, you look at the position along the guide and you don't know what's going on. So at this position, you have a normal plane from here. You can drop a normal to the spine, and somehow this graph is positioned or regenerated here. That's what the documentation says. But what do you mean by regenerated? Okay, what do you mean by position? They don't tell you the story. And then these things are all attached to each other, and you get to surface. Now, the only two cases that I'm going to make are again super simple because at least the options can be explained in the case of these super simple situations. But there is a lot more to it. These things will not look as trivial as it is when you go to more complicated not spline, spine, etc. And and uh, the mean plane of a spine. Now these things, what I have done here, I'm going to quickly show you what it is. But I will come back, or you will come back if you think there is more explanation needed. Try to read some of the stuff, which is unfortunately not from the sub. So this is all from AI Google. I'll go through it just so that you have a reference. This is the second one. Because remember, the case that we're discussing is explicit with a reference surface. But the question becomes, what if I don't have a surface? What happens there? Okay. What if I have only one spine and the guide curve, and I don't have a guide curve, so I have only a guide curve, okay? So in that case, that spine will be the guide curve, okay? They don't have to be different. What does that mean? Initial positioning, or repeated and reposition. Stuff that I talked about in the first couple of minutes. And that's it. This is the last one. All right. So let's go ahead here. And just like I told you, because it's easier to explain some of these things for the super simple case. So what I'm going to do for my profile, I will do only half a circle. So I go there, half a circle. My units are in millimeters, so that's okay. So I'll leave it as millimeters. That's really not the point here. All right, I'll give this thing 10 millimeters. All right, and I will make a distance of 20 millimeter from here to here. This is in case you want to follow me. So there is my profile. Then I'll do two sketches. One of them is going to be straight line. The other one is going to be a spline. Okay. So the first one on that horizontal plane, I will sketch a line that goes like that at 45 degrees. So first of all, let me dimension this thing just for the sake of completeness. So I make this 100 millimeters length. Okay. And for angle between this and that, I'll make it 45. Good. Exit. So this is going to be my sketch number 2, which is going to be that line. Okay. So actually, it may be a good idea if I call this thing, I'll call it semicircle. Let me rename these things. So under, I'll call it a semicircle. Okay. Excuse me. On this one, I'm going to call it line. That's the path, line path. Or let me call it guide curve, guide. Or I'll call it path. How about that? Okay, so that takes care of this. Then I'm going to do another path on that same plane, on that same XY plane. I'll do another one, and I use these endpoints for that line. So let me do a spline here. So I go here like that, and maybe like this. Okay. Now obviously I have to attach this to that endpoint. Control. I want to do that because I don't have to, but I want to do it. Right click coincidence. Okay, good. Exit. All right, and I'm going to call this thing a spline path. So properties, spline path. All right, very good. So let me save everything. Okay, so now we go to the surface tab. Here's the surface tab. If I'm not there already. And there is this sweep. And notice that this is the one that says explicit. And notice that we have three options here. We are just discussing with reference surface. And notice that I don't have a surface here. If I did have a surface, it is possible for me to select that, and it will be used that surface, the normal to that surface, essentially used to position the uh, profile or the regenerated or the recomputed profile using that normal to the surface. But I don't have it here. Okay. So the question is, what is it going to be using? Well, first of all, what is the stuff that I'm talking about? So that goes to these slides that you see here. Okay. Uh, so this is where you're going to be, uh, you may have to go back and forth at your own leisure between these things. See, if a surface is not specified, CATIA will use mean plane of the guide curve or the spine. The question, what is the mean plane? So you go to the next set of things and you will find the definition of the mean plane. Let me see if I can find it here. The mean plane was, if I'm not mistaken, was defined not in the DASA documentation, but right here. When a 3D spline or a curve is used as a spine, CATIA calculates the mean plane that best fits the curvature of that spline to serve as the reference surface. There's a lot more into that shape that you're getting on the screen than what meets the eye. So let's go ahead here. So for profile, this is my profile, semicircle. For guide curve, I have only one guide curve, and I'm going to do the line first. See that? This line first. And notice that there's no spine here, but because there's only one guide curve, when I select it, automatically it comes over the surface, right here, comes over the surface, the mean plane of the spine. Where did the spine come from? Because there was only one curve, it uses that one guide curve as the spine and its mean plane. Okay, now, very simple, not a big deal, just a preview. It's going to be something that goes down this path like that. It's very easy to see this. Okay, and in fact, if you look at this, you can think about it as a tube, but this the diameter of that tube is you know, actually you can, let me show you something. This is okay, no problem. Or let me hide this parabolic thing or not the spline thing. So let's find out what is the cross section. What is the cross section of the uh, normal to the spine plane and this? Is it going to be a circle? That's my question. Is it going to be a circle? Let's find out. So let's go ahead and first of all, find a point, a plane normal to that. So let's go to wireframe. Here's a plane, normal to a curve, normal to a curve. Let's see if we can find it here. Normal to a curve. Where's the curve? There's the curve. Okay. Now, at what point I want to create a point on it? Create a point on a curve, on a curve. So let me take this point. Okay. And then this point, for example, and then say, okay, notice that it creates a plane normal to the spine, normal to the spine, normal to this line at that location, and then we say, okay, now let's find the intersection of this with that uh, generated surface. So we go to, again, wireframe, intersection of this surface with that plane, and then we say, okay. It gives you something. The question is this something? A circle? The answer is, we'll see. What is the distance between this point and this point? The height is 10. We know that. This distance from this point to this point, if you go to tools, is not going to be 20 because remember the radius of that profile that I drew was 10, so the diameter was 20. But this distance is not 20, and if you measure it, you can see that. from here to here. Definitely not 20. You can see this. So that takes care of this. Now let me hide this. Let me hide this sweep. Let me hide it. Let me hide this plane. And this intersection and that line. Hide it. But I want my spline path to show up there. Now let's do another sweep. Surface, sweep. Here's the profile. There's only one guide curve that I have, and it's this. And as soon as I do that, it uses that as the spline and uses the mean plane of that, whatever that thing is. Remember, you have to go back to these things to find out what it represents. And those are not quite complete. I can tell you that these things are not complete. So in reality, you have to go to the documentation for 3D Experience CATIA or /CATIA and find out those people who wrote these things 25 years ago, what did they do? Can you find it? I'll be very surprised. Anyway, so guide curve is this and preview. So it gives you that. Already we know that for the case of a straight line, that was not even a cylinder with a circular cross-section. It was elliptical cross-section. And you can see that things are getting uglier here. And whoa, let me do something else. Let me go and make a wheel. Oh, before I do that, while we're here, let's do the following. Let me go to that sweep that I made. There's some stuff there that we want to look at. The optional element. One of them is called the, for example, yeah, you really don't have much else to do here. You can't fool around with these things. These you can't do that right now. All right. So one thing we want to do is this business. See that it says add cutters here. Add cutters right there. You click on it, and it says select a point on the master guide. Here's a master guide, so we select a point here. Notice that it added the cutter, and notice that if you zoom in close enough, it's got two arrows, one left, one right. So if you select the one on the left, it moves the cutter to the left, and you select this arrow, it moves it to the right. And if you say preview, what it doesn't show you the stuff in between these two. Preview. Okay, let me go back here. Uh, I have to eat my words, but say uncheck this, fill twisted area. Okay, fill twisted area. Uncheck that. Now preview. The, the reason that you need these, or you may use these cutters, is that your surface is going to be ugly. So you're going to be cutting it to remove that ugliness. When you remove that ugliness, it fills this thing in some way, okay, the twisted area. And if you want to see it, just click on it. You're going to see that. In this case, there's no twisted area, but anyway, you can do that. So cancel that. So we know what that cutter does. Now let's do another one. I want to do another uh, I want to do another sweep. So on that plane, again, I will sketch. I'm going to do a really ugly spline. So for example, something like that. Let me do a spline. Starting here, it really doesn't matter. All right, something like this. Exit. Okay. So let me hide the sweep. Let me hide that stuff. And now, this last one, by the way, was ugly spline. Okay, this is sketch 4 was the ugly spline. So we go to surface, sweep, here's the profile, here's your ugly spline, and preview. It's going to go like that. How in the world, what in the world is this? Looks like a bunch of sausages tied together. So what we can do is we may be able to use create cutters here so that it just gets rid of some of the stuff. This looks really bad. So let me go here, make it to look a little bit better. Yeah, okay. So let me try that now. Still bad, but that's okay. It's still a little bit better. So if I double click on this and I say add cutter, and notice that it says select the point on the master cutter. So let's say I select this point. Now notice what happens when I say preview. Oh, it did create some stuff here. You can see that, create the cutters here. I can move these to some locations that I may find it appropriate. Ah, there, see that? Right there. And this other fellow, I'll move it to the other side. Uh, it's going to be kind of difficult hanging there. It's really bad. Not having a lot of oh I'll just leave it like this for now. I don't like it, but because I want to move it back and I'm having a hard time doing this, so maybe that's a problem. But anyway, let's leave it like this. Say okay. Okay, but I don't want to fill the twisted area. So if you go back to that sweep, I don't want to fill the twisted area. Right now, with those cutters, it looks better, but I don't want to see that there. Okay. Now, this was not good enough in a good location that I wanted to. I couldn't move it. But here it says there's two pieces. You want to keep both of them. If you say yes, then it'll create two extracts and puts it there for you. Okay. So we know that, where was this? If you double click on this, cancel that. Sorry, if you double click on sweep. So we have, one thing I have not shown you is this business of relimiter, okay? So let me cancel that. I'm going to hide this, and hide it. Okay, where is it? Uh, oh, these are the extracts that are not hidden. I can hide it or delete it either way. But I want to go back to one of these points one of these surfaces that I did. So let me see if this one, for example, hide and show. Good, good, good. Now, uh, actually, let me go to the one. This is still the ugly spline, so I don't want that. I want to go to one that was, uh, maybe that was good. That was a good one. Sorry, this was the good one. Yeah, this was the good one. It's just that the spline I don't want to see. Good, good. And remember, this was along that nice spline and right there. Good. Fit. Where's the fit? Okay. So let me turn this thing around. You know what we did? Here was the profile was here, the spline was there, etc. Now, if I double click on this, oh, I had some cutters here. So actually, let me do the following. Let me say remove. Remember, I cut it at these two locations. So let's say remove cutter on display. Don't fill the twisted. Let's see what happens here. Oh, it's easier if I did this thing again. Let me do it again. Okay. So I don't want that. which one was, these are the extract that are showing up. I don't want to see these. Let me do it again. So I go to surface, sweep that profile along this guide curve, which is going to be automatically spined. Now notice that first of all, we can say preview. Good. But there is incidentally, on the screen, you also give the representation of what your default reference plane is right there. Okay, that's this thing. Okay, you can change these, and as a matter of fact, later on, I'm going to change it in a minute. Let me do this. Let me do this. Before I do that, let me change this thing to something weird. Let me see now. For the surface, instead of the default, I'm going to use. Let me try something that makes it crazy. Let me try XZ. See whether that works. It really destroys the surface. I don't want to do that. Cancel, cancel. Or I can clear this thing, go back to the default that I had. Okay, so now I want to use relimiter. What that means is that I don't want the whole thing. I want to go between 2 points. So if you click on the relimiter, you can create a point here, insert a wireframe, create a point on the guide. So this point, for example, that's one. Say okay, okay. And another one, if you want to do another one, if you want to do it, wireframe, another one on the sky curve, which is our spine, by the way. So say okay. And if I say preview, it shows you only the stuff from the sweep between these two relimiting points. There we are. Now, there is also these two items which says smooth sweeping, angular correction, and deviation from guides. I mean, in the nutshell, what they're saying in those AI generated reports and some of the stuff that you see in the documentation is that if your spine is not smooth enough, you can actually force it to be smooth by changing this parameter here. You can change this, okay? Or if your spine deviates from the guide because of what is done internally into the internally in CATIA, and you will never do what is done unless you have the implementation, theory manual, etc. And if that's what you're interested in, okay, then you can change that by changing this value specified, default value specified, okay, and say okay. I want to show you one more thing. Let me do this thing. Let me actually do this thing with the line again. So I can hide this. Let me go back to another sweep. I'm going to do that with respect to the good old line here, which was this line path. Okay, and say preview, and say okay. Some of the stuff that I don't want, I'm going to hide this. Okay, and my line, if it's helpful to you, I'm going to show it to right there. Now, if you double click on this, down here, there is something called positioning parameter. If you click on the position profile, it says, show me the parameters. You selected this, show parameter. It says, okay, do you want to offset these things by some amount? For example, let me make this thing 30 millimeter in the, let me make it 50 millimeter in the X direction. And these are the local X and Y, and maybe 80 in Y. Okay. Now, first of all, I can't reach my okay. I mean, because the okay is down below, further down below. So what I can do is to say, I put these numbers here, and I say, just don't show me the parameter, hide the parameter. So now you can reach this preview. Look at what happens to this surface, which is right here. If I say preview, it moves to another location. So by this, you can move it to a different location. There is also one other thing here. If I say show position, okay. There is also this angle here. So let me make this thing 45 degrees. With respect to, I'll make it Z, with respect to the Z axis. Let's see what happens. Now I can't reach the preview, so I have to close this and then preview. It rotates it. It not only moves it, but it also rotates it. So in the optional element, you have these things that you can fool around with and get something. And the problem with get something is that it may look good, and you're an excellent Class A designer, you generate a very nice looking stuff as the customer wanted, but you don't know how it happened, why it happened. In general, I mean, there's a lot of, some of it you can figure out, but there's a lot of it that's unknown to us. Yep, so you can see why these things are useful. Good luck.